Mission is simple: to help high achievers naturally eliminate emotional and physical obstacles so they can optimize their life for higher achievement. Welcome. You have just entered the Genesis Zone. Good day and welcome to the Genesis Zone show. This is Dr. Brian Brown. Thank you for taking time out of your busy schedule to join us on this beautiful Thursday. Have you or someone you know ever dealt with anxiety symptoms? That includes panic disorders or panic symptoms, obsessive compulsive symptoms, or post-traumatic stress disorder symptoms. In today's episode, we're going to be talking about what is causing this anxiety and stress and whether it's generational or not. It's hard to talk about the generational impact of stress or anxiety without talking about pregnancy. This first study that I'm going to share with you today talks about the incidence of anxiety issues in offspring of mothers who've used cannabis in the past or who used cannabis during pregnancy. Now, it's pretty common anecdotal perception among cannabis users that cannabis actually decreases anxiety. And population studies even validate this thinking among cannabis users. But what does the research actually show? Well, the research actually shows that cannabis may actually help with anxiety in the short term, but it can also lead to a rebound effect of worsening anxiety, thus the need to kind of go back and use more frequently. Now, with that in mind, let's look at cannabis use among mothers, as was pointed out in this study, and how it affects their offspring. Researchers from Mount Sinai Medical School published their findings with the National Academy of Sciences. And this was a long-term study where they followed children through their developmental years who were born to mothers who used cannabis during pregnancy. They found that mothers who used cannabis during pregnancy were more likely to have children who struggled with poor stress responses, anxiety disorders, agitation, aggression, and hyperactivity. Now, this is really interesting. And here's what the study didn't answer. And I feel like there are three important questions that should have been asked of the study that were not answered in the study. Number one is, what was the epigenetic makeup of these mothers? Do we know epigenetically where they stood in their ability to manage stress or their propensity for anxiety disorders in the first place? The study didn't bring that out. And my hunch is they didn't even look at it. I think in future studies, we're going to have to start looking at these epigenetic links in order to start drawing some more, dare I say, logical conclusions or more detailed conclusions about this. It's just smarter science to epigenetically profile people when we're talking about these types of outcomes. The second question is this: were these mothers subjected to stress or trauma during pregnancy? You know, research shows that women who are subjected to stress or traumatic issues have offspring who have aberrant stress responses. I mean, it's just common knowledge in the research community. Obviously, it wasn't so common that it got included as a question here, but it should have been. It should have been part of the pre-screening, like what was their stress like during pregnancy, and did they have any trauma history during pregnancy? And the third question is this: did the mothers have any pre-existing psychiatric conditions? I mean, it's a really important question to ask. And I think we have to ask the same thing of fathers. The study did not bring out the same questions for fathers. You know, did the fathers, what was the epigenetic makeup of the fathers? Were the fathers subjected to stress or trauma during pregnancy? Because again, if a father is subjected to stress or trauma at the time that they conceive that child, help conceive that child, then there's also evidence that that does affect the offspring. And the third question for fathers would be is, did the fathers have any pre-existing psychiatric conditions that could have been passed down genetically to their offspring? We just don't know. In a minute, you'll see why I'm concerned with these questions, as I'm going to kind of tease through that. So while it's easy to conclude that A plus B equals C, or a mother that uses cannabis during pregnancy gives birth to an offspring that has anxiety, agitation, irritability, and hyperactivity, there's still a lot of questions that we don't have answers to. So I don't put much stock in this study. Yeah, they did it. The information's out there. Unfortunately, it's going to get used in the wrong way. I think there are other reasons not to use cannabis during pregnancy, because there are over 170 chemical constituents in cannabis that we just really don't know the biochemical activity of, much less in the human body, an adult human body, but we don't know the biochemical activity in a developing baby. So that's the reason I say stay away from it. But there's still a lot of unanswered questions, and being able to draw a correlation like they tried to draw in the study. All right. So while we're on the subject of stress during pregnancy, it goes without saying that global stress has been reported to be at an all-time high over the past couple of years, with the pandemic looming large. And now we've got talks and rumors of war also looming large in the minds of nearly everyone. So this next study brings to light some important data. During the pandemic, screen time and sitting time, or seated time, drastically increased. Everybody knows that. In fact, there's hardly anybody you can talk to that didn't struggle at some point with saying, "Oh, I've gained the pandemic 20, like the freshman 20 when you go to college." And it was from being very sedentary. Unfortunately, sedentary life, extra screen time, did not bode well for our mental health overall. Researchers at the University of Dublin found that mental health outcomes actually declined significantly the more exposure a person had to screen time, and the more exposure that person had being sedentary and sitting. In fact, it negatively impacted young adults and women more than any other group, to the point that they had higher rates of depression and they had higher rates of anxiety. Now, again, this study brings to light some important issues. Pandemic or no pandemic, we are becoming a more digital society. And it's common knowledge that as such, we are sitting more, we're not moving as much, and we have to be more purposeful and mindful about that. It's common knowledge that exercise, moving your body on a regular basis, is essential to good mental health outcomes, such as improving mood, lowering anxiety, and improving your responses to stress. Now, so far, we have a few really good causes for anxiety and poor stress responses. Number one is loosely cannabis use during pregnancy, which still has a lot of unanswered questions. Number two is too much screen time. And number three is a sedentary lifestyle. But now I want to circle back to the generational question. I think it's really important here. In previous episodes, I have discussed on this show how research actually has proven, especially among male mice and mouse models, when these male mice are subjected to stress at the time that they help conceive a litter with their mate, these male mice will pass along stress signatures in their DNA to their offspring. Now the crazy thing about this is that this generational effect happens for up to 7 generations. Now, here's another study as it relates to mothers and motherhood stress. Researchers have discovered that mother roundworms, and I know that's crazy, but roundworms, when they're subjected to stress, it also causes that same stress response behavior, as well as other biological changes, to pass along to their offspring. And this can be passed down for 4 generations. So with male mice models, we have it, stress responses being passed down for 7 generations. And in female roundworm models, we have the stress response being passed down for 4 generations. I mean, it sounds familiar, right? I mean, we're seeing these two different types of animals in the animal kingdom. They're able to pass down these stress responses for multiple generations. So my question is this: is your father or your mother, or because we look at it generationally, your grandfather or your grandmother from 3 to 6 generations ago, are they the ones to blame for your anxiety and stress response issues? Better yet, is the stress, trauma, anxiety, or emotional pain that those ancestors experienced, is that to blame for the anxiety and wicked stress responses that you have today? Well, if you believe the research, it's highly possible. Now, I know that you may be thinking, we aren't mice, and we certainly aren't roundworms, and this is true. But it leads me to the next thought. Being a curious person, I automatically default to ask, why? Why is this phenomenon happening in the animal kingdom anyway? Why are we passing stress responses down from one generation to the next? And I think the answer is blatantly that generational epigenetic alterations are the culprit. And the answer to why this is happening is simple. It's a survival thing. We as animals pass down an alteration in the epigenetic code so that the next generation innately knows to be more cautious, to be more careful, to be on alert more, and therefore that next generation has a higher likelihood of surviving to bring forth the next generation. The unfortunate baggage of this is that we as humans don't have to we don't have to run from saber-toothed tigers anymore. Now, what does that mean in this day and age? Here's what it means. So if one generation is on average 25 years, according to epidemiologists, then we're talking about 175 years if we're looking 7 generations out. So that's 175 years worth of epigenetic information that is being passed down. So within your body, you could potentially have 175 years or more worth of epigenetic information related to stress. Now, with this in mind, knowing that stress has been at an all-time high the past couple of years, what have we done to ourselves and our offspring and their offspring and their offspring and their offspring, and so on down the line? Well, I think because stress has been at an all-time high, unprecedented of in our common knowledge of history right now, this is totally different in current recorded modern day history to be under this amount of stress. What are we doing to our genetics that we're passing down to the next generation? And I think that's a bold question that we have to ask. And what can we do about it? I do have some answers for that, and I'll give you that in just a second. So where can the breakdown be occurring? Well, there are actually 2 places that I believe it happens, because I see it clinically, because I work with epigenetics. And I think number 1 is the COMT gene, COMT, that's all caps, COMT gene, and the GAD1 gene, GAD-1, GAD1 gene. Let's talk about the COMT gene first. COMT itself stands for catechol O methyltransferase. You don't need to get caught up in that. Please don't do that. It's not important, but it's just easier to say COMT, right? So COMT is actually an enzyme in the body that's very active in certain organ systems, such as the brain, the adrenal glands, the liver, the kidneys, the lungs, and the intestines. So why is something with such a complex name so important? Well, the COMT gene, which controls the activity of the COMT enzyme, plays a critical role in the breakdown of dopamine, norepinephrine, and epinephrine. In other words, it controls the breakdown of dopamine and adrenaline. Now, it does this by donating a methyl group, thus the name catechol O methyl transferase. It transfers methyl, donating a methyl group to help break down dopamine and adrenaline. And there's a complex process I won't go into that involves acetylenolmethionine and so on and so forth. We won't get off into all the biochemistry of it all, but just know that the COMT gene is responsible for donating a methyl group to help break down dopamine and adrenaline. Now, why is this important? Dopamine is a neurotransmitter that's involved in mood, and adrenaline is a chemical that's involved in your fight or flight response. Dopamine being created and generated in neurons in the brain, and adrenaline being created by your adrenal glands that sit on top of your kidneys. Now, when the COMT gene is working properly, either by its own programming, or you have really good methylation, or you have a combination of both, it leads to higher levels of the COMT enzyme. And this means that it's easier to break down dopamine and adrenaline, which is a good place to be. All right. So when you're able to break down your dopamine and adrenaline properly, this means that the neurotransmitter dopamine and the fight or flight chemical adrenaline aren't as available as much for use. Now, if there's a breakdown in the methylation process, or the COMT gene is not functioning properly, meaning it's underactive, then there's a buildup of dopamine and adrenaline, which will lead to anxiety and feeling the physical symptoms of stress more frequently than other people do. So you want a scenario where you're able to break down dopamine and adrenaline. If you ever get into that scenario genetically where you can't break down dopamine and adrenaline, that's when you start dealing with anxiety and stress responses. Now, allegedly, and this is some fairly older research over the past 10 years. We don't have any up-to-date current research in the last few years, but allegedly, researchers tell us that approximately 10% of the population have this COMT gene variant where they don't break down dopamine and norepinephrine well. However, I have to add to this that there haven't been enough large studies where epigenetics have been checked in people that actually validate this finding. These are extrapolated data, meaning they took very small groups of people and they just said, oh, well, it's about 10% here, it's about 8% here, it's about 12% here. It averages out to about 10% in these few small studies. So it's just 10% of the population. In my clinical experience, I actually see it more frequently than 10% of the time. I don't know if it's the population I work with or it's just that way in general, but I see the COMT gene variant being an issue quite commonly among the people that I work with. I'd also add that since poor methylation is another contributor to the functioning of the COMT gene, the problem still exists with poor breakdown of dopamine and adrenaline. So we not only have to look at COMT, we have to look at COMT plus methylation. So it's a combined effect. You can have good COMT gene activity, but if you got poor methylation, the COMT is not going to function like it should. It's not going to donate the methyl group like it should because there just won't be a methyl group there. So, because again, that biochemical process I said we're not going into, it's a downstream effect. If we're not methylating well, we're not making the chemicals that COMT needs in order to be able to donate that methyl group, and it's just a cascade effect. So you've got to check the whole scenario in order to understand what's going on. So next up is GAD1. Now, the GAD1 gene is responsible for the breakdown of glutamate. Glutamate is an excitatory neurotransmitter in the front part of the brain. And you need glutamate because it allows you to feel emotion. It allows you to get excited about things. It allows you to be alert and attentive and things like that. However, if you don't break down glutamate and glutamate builds up too high, guess what? You have anxiety and you have poor stress responses. The offset to that is a chemical called GABA. So it works in a seesaw fashion. So if glutamate is too high, your GABA levels are low. And GABA is that neurotransmitter that's very calming. So you've got this one neurotransmitter, glutamate, which is very excitatory. It actually increases your anxiety. And you got one that's GABA that just kind of puts the brakes on the system and brings you down. It's more calming. So this is why that's why when you look at research studies, research shows that melatonin is a very good choice to decrease anxiety. Obviously, you're going to want to give melatonin at night. I've got some clinical reasons why it could be used during the day, but I don't recommend it publicly. It's on a case-by-case basis, and it's on an emergency basis. But melatonin used at night will bring down glutamate levels and it will raise GABA levels. And that's what you want to do. So it will help control anxiety. Just a little insider secret there. So if you're struggling with anxiety issues and not quite sure what's going on, or you're a biohacker and you simply want to take your biohacking journey to the next level, to the highest level possible, maybe it's time to learn about how epigenetic profiling could be the answer for you. I've created a 5-day boot camp called the Gene Hack Boot Camp. And by the end of the 5 days, you'll have a keen understanding of exactly where you need to focus your efforts in your wellness journey and in your health recovery. You'll learn about the exact genes you need to have tested in order to address any hangups that you may have. And you'll learn some of my favorite genetic modifying natural treatments like melatonin. Also, you can begin to feel better and feel fully optimized, and ultimately, so you can live life the way you want to live life. It's that simple. So right now we're running a promotional special, and the boot camp is free. I've said this for several weeks now. I can't promise how long it's going to be that way. Maybe we're going to keep it that way forever. We're testing it right now, but there's going to come a day that we're going to test it actually at an investment, and we're not sure what that is. But right now it's free, and you can take advantage of this deal and enroll in the boot camp for free by going to drbriangBrown.com/gene hack/boot camp. You can see it right there on my screen right now, and there you'll be able to register and take the first step to getting the answers that you deserve. So that's all I've got for today. Tune in next Thursday at noon Eastern Standard Time for our next In the Zone segment, where I'll be sharing the latest research and my insights about that research as it relates to optimizing your genes, optimizing your physical and emotional wellness journey, and biohacking yourself, your body, your mind optimally. Most informed, most trusted, and most grateful you spent this time with us today. Until next time, stay in the zone. I'm Dr. Brian Brown.